Let's read the problem below, then use what you know about scale drawings to redraw a scale drawing using a different scale. An architect is designing a recreational center for a community park. Below is her sketch of a swimming pool drawn on centimeter grid paper. The scale of the swimming pool is 1 centimeter to 5 meters. Redraw the swimming pool using a scale of 1 centimeter to 10 meters. Okay, 1 centimeter to 10 meters, not 1 centimeter to 5 meters. In the architect's sketch, each small square has sides 1 centimeter in length. Picture it. You can compare the measurements in the original scale drawing to the measurements in the new scale drawing. In a new scale, 1 centimeter represents a longer distance than it did in the old scale. This is the original. 1 centimeter is 5 meters, 1 centimeter, 5 meters. Now it's 1 centimeter, the new scale, 10 meters. The measurement of each side in a new scale drawing is half as long as the measurement of the original scale drawing. Let's connect it. Now you will solve the problem on the previous page and show that the actual dimensions of the pool are the same for both scale drawings. Each square on this grid represents 1 centimeter. Draw the swimming pool on the previous page using the scale 1 centimeter to 10 meters. Question 10. Calculate the actual dimensions of the swimming pool using the original scale. 1 centimeter to 5 meters. Question 11. Calculate the actual dimensions of the swimming pool using the new scale 1 centimeter to 10 meters. And question 12. Explain how you can tell if your new scale drawing is correct. So what we're going to ask you to do obviously now is pause this video, solve these 4 questions, and once you're done solving them, unpause the video, and then you can check your answer. Question 9. Each square on this grid represents 1 centimeter. Draw the swimming pool on the previous page using scale 1 centimeter to 10 meters. Okay, and they did that here. Okay, there it is. And you can also use this. Question 10. Calculate the actual dimensions of the swimming pool using the original scale 1 centimeter to 5 meters. So, the length in the drawing is 10 centimeters, right? 10 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the width is 6 centimeters. 1, 2, 3, 4, 5, 6. So the actual length is 50 meters and the width is 30 meters. Right? Okay. Question 11. Calculate the actual dimensions of the swimming pool using the new scale 1 centimeter to 10 meters. It'll be the same. Okay? Except the length in the drawing is 5 centimeters and the width is 3. 5. 1, 2, 3, 4, 5, and then 1, 2, 3. Okay? Explain how you can tell if your new scale drawing is correct. Well, the actual dimensions of the object should be the same using both scales. Right? If we go back here, they are the same. They tell us that both scales are the same in this case. Let's try it. Use what you just learned about redrawing a scale drawing using a different scale. Show your work on a separate sheet of grid paper. The scale of the rectangle at the right is half centimeter, for every half centimeter, to 4 feet. So think about that. 1 centimeter will be 8 feet, right? The length of each square on the grid represents half centimeter. Half. 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 Okay? Draw the same rectangle using the scale half centimeter to 2 feet. And then find the area of the actual rectangle. So, again, pause this video. When you finish answering that, if you get stuck, you can go to to the previous question we just went over. And then when you're ready to check your answers, just unpause and you'll see the answers. Let's look at the answers and then we'll break it down for you. Draw the same rectangle using scale 0.5 centimeters to 2 feet. So your dimensions on the grid should be 8 grid squares wide, not 4, double that, and 12 grid squares high, so double that as well. We'll draw that soon. Find the area of the actual rectangle, and if you got 384 square feet, then you got it correct. Now let's break this down so you have a better understanding of how we got the answer. But first, let's look at this grid. It says the scale of the rectangle at the right is 0.5 centimeters, 4 feet. So every one of these, let me do a different color here. Every one of these is 4 feet. So this is 4 feet, 4 feet, 4 feet, 4 feet, 4, and 4. Same thing here. 4 feet, 4 feet, 4, and 4, right? Every half is 4 feet. So it's basically 24 feet by 16 feet. And if you multiply them to find the area, you would see that it's 384 feet. So the question, how in the world is this 384 feet as well? Well, let's show you. Okay, if you get stuck, you can always pause the video and rewind and look at it again. So now, let's draw the grid you should have had. So we're going to add 4 more here. 1, 2, 3, 4. Right? So the total here is 8. Correct? And then we're going to add the 6 and another 6. Let's go back to make it easier. There's the 6 and then another. 1, 2, 3, 4, 5, 6. And then we're going to close this. It's kind of like having, okay, 4 of these. Picture that. Okay, so this will be 12. All right. At 2 feet, every 0.5 centimeter is 2 feet. So if we have 12 of these, again, we have 24 feet. Okay. I mean, I can go one by one so you can see it. 2, 4, 6, 8, 10, 12. Right, and then 6 more. 14, 16, 18, 20, 22, 24. Right? So that's why it's 24 feet. And again, 8 times 2, 16. If you're not sure why, again, 2, 4, 6, 8, 10, 12, 14, 16. Okay, everybody see that? And 24 times 16, the area will be 384 square feet. If you still are confused, obviously pause the video, rewind, go back, and you can check it out. And if you're still confused after that, just come see me or ask me.